welcome. I guess we're just gonna jump right in. It's a bit after 4, so hopefully you're here to hear about how we use graphs and GraphQL for identity and access management. Yeah? Okay, good. So I'm Alex Babeanu. I'm an identity solutions architect and specialist at Nulli. We're a consulting firm based in Canada, but we have lots of clients here in the US. Actually, we have a client a couple of blocks away. We do mainly and only identity and access management solutions. So you may wonder what I'm doing here. As it turns out, graphs have been quite helpful in solving some of our problems. And that's what we're going to explore today. Now, as identity and access management professionals, one of the first things we need to really define and make sure we all agree upon is what an identity actually is, right? What is an identity? Well, at first it seems like an easy question because we all have an identity. We all are aware of it. Some of you might have several, I don't know. But it's something we are born with, and from an early age, we have a notion of it. For example, when I was a kid of 8 or 9 years old maybe, I was already a huge fan of science fiction, right? All my toys looked like this. And so I would stage like huge battles between all those toys, but eventually I would run out of toys. So what I would do is I would start integrating more mundane objects into my games. Things like this, for example. Recognize that? Evil alien species, right? Yeah, I was already quite a nerd back then. I had a lot of these things as well. Smart missiles, yeah? Or the most deadly of all, the most fearsome, these things. They spun really fast, acted like saws and could go through anything. So anyway, the point of this is that even at an early age, I could easily interchange the identities of my objects and still be able to play. I had an understanding of it. But here's a tricky question for you. Can anybody actually give me a formal definition of what an identity is? This is not a rhetorical question. Any volunteers? No? All right. That's what I thought. So this is what I'm going to talk to you about today. First of all is, what is an identity? We're going to explore that. And then I'm going to give you a very quick, high-level overview of identity and access management, a couple of slides. And then we'll look at the problem that we're facing nowadays in that field and see how graphs can provide a solution for those problems. And last but not least, we'll look at GraphQL and how it fits in the solution. And we'll have a quick look at the grandStack. Sound okay? So, jumping in, this is basically how we define identity. We at Nulli, and we think that it applies to a lot of cases. It helps us figure things out, really. So first of all, an identity is something that has a set of properties. I mean, this is true for a lot of things, but especially true as well for identities. Cool. The second thing is that an identity is an entity that needs to be authenticated and authorized. So what that means is that it's an actor, it performs an action, and that action needs to be authenticated and authorized. That's probably the most important one, actually. The third one is that identities are always related to other entities. An isolated identity is not really interesting. The mere fact of an identity trying to access a resource creates a relationship between them. So an identity that would be isolated would be, well, we could just discard that, right? So what fits into those definitions? What examples do we have? Users, of course, people have identities, but also smart devices, your mobile phone. But cloud services fit that description as well because they often communicate with each other. Last but not least, IoT devices. Like for example, here we have a smart sensor, or examples from the smart city with smart parking meters and smart lights. All of these are identities. So far, so good? Okay. So what is identity and access management? What are we trying to do? So what is it? It's basically, identity and access management is basically those 3 pillars. You have identity management per se, which deals with identity lifecycle, meaning creating, updating, deactivating identities. User account provisioning, like creating a mailbox or creating accounts on your apps or in-house resources, as well as role management, like identities have different types of accesses, Maybe they need different roles. So all that is part of identity management. And it's basically, it has to do with how you structure your data. The second pillar is password management. So anything that pertains to changing your password, updating your password, or in case of devices or smart objects, it's things like storing secrets or storing certificates and how you manage or handle those certificates. The last piece is access management. And that is what happens at runtime when an identity tries to access a resource. That's where we have the authentication and authorization. You have things like single sign-on, identity federation across different domains. You have n-factor authentication and all of that. So we'll see that we found that graphs really help us with that, with access management. So we'll focus on access management, at least on this session. So access management is made of two main pillars, authentication and authorization. Authentication is like the front gate to your castle, is where you ask the credentials of your identities, and if you're happy with the credentials, then you let them in. And once they're in, they're in. Now, typically, we would store identities, the identities, in not in a graph, but in an LDAP directory. This is going to stay, but so typically we see that authentication is performed by LDAP and not by graph, which is fine. Authorization, on the other hand, is what happens when the identity is in your domain, is inside. So it drives what room they have access to and what feature they can access, and maybe even what data point. This can be as granular as you need it to be. So you can specify which specific nodes they can access and so forth. And we'll see that this is where the graphs play a big role for us, authorization. So now that you're all identity management experts, shall we play a little game? You'll see it's quite easy. We're going to test your new knowledge. So what we're going to do is I'm going to show you some pictures and ask you to raise your hand if you think the thing I'm showing you has an identity, okay? So firstly, now I grew up in the 70s and 80s, so the first things I'll show you, well, populated my universe back then. I mean, you'll see. First one, easy. Everybody recognizes HAL 9000 from 2001 Space Odyssey. So identity or not? Yeah, a few hands, yeah, okay. Yeah, you guys are right. It has an identity, right? How about R2? Identity? Yeah, okay. Now, a little trickier. How about this? What is this? This is how I can tell where, if there's some French people in the audience usually. Yes, this is a Minitel. Everybody knows what the Minitel is? It's basically a keyboard and a screen packaged in the same box. It was created in 1982. And through that, you could access some remote services, remote servers. And the types of services you can access with this thing were things like consulting your bank account, buying tickets to plane tickets or train tickets. There were online forums. There were even dating sites. So it was super popular in France because it was really easy to use, practically free, and really promoted by the French government. I think we can safely say that the French invented the internet before everybody else. Anyway, I'm just throwing it out there. So what do you think? The Minitel, identity or not? Actually not. It's a dumb terminal. The only identity in that scenario is the users. Yeah. Let's fast forward a little bit. Nowadays, smart fridge. Does it have an identity? Yeah. How about this? What is this? Anybody? That's the condenser that lives in the fridge. It's the thing that cools your food, right? Does this have an identity? Anybody? Good one, good one. Well, the right answer is, it depends. Well, here's the thing. Remember the definitions? Does it have a set of properties? Yeah, it has definitely some properties that I don't know anything about. Is it related to something? Well, yeah, it's obviously related to the fridge because it lives inside the fridge. Does it need to be authenticated and authorized? Well, that's why it depends. If you need this thing to do something, then maybe yes. So you see, it's not quite easy all the time. How about that, connected vehicle? Yeah, for sure. There's actually quite a lot of interesting use cases around the connected vehicle nowadays, lots of work being done. Very interesting use cases, like if I lend you my car, but I don't want you to go over, say, 70 miles an hour. Or I lend you my car, but I don't want you to be able to open my glove box. Things like that. So quite interesting. Last one I have is this. How about this? This is a smart sensor, right? It's there to measure something that happens in a pipe, so like a temperature or flow or pressure, and it uploads telemetry data to a cloud service. Identity? Yes. All right. So what was the point of this little game? Well, back in the 70s and 80s, the only things that had an identity were basically fictional characters, right? Now, we're not even sure if our condensers in the fridges have an identity. So we're seeing a dramatic increase in the number of identities we have to deal with nowadays. And therein lies our problem. What is the problem? Well, these are a couple of diagrams that, there's a bunch of diagrams that you can find like that on the web. And what they show is that an almost exponential rise in the number of IoT devices that we will see by 2020. Actually, by 2020, they predict 50 billion IoT devices out there. That's a lot of devices. That's a lot of new identities. Just add on the number of humans, the number of telephones, the number of services, and you really realize that you have an explosion in the number of identities we have to deal with. And who says, so besides that, we have an explosion in the number of relationships, because remember, identities are never alone. For example, our smart sensor here lives in a refinery, and the refinery has workers that need to access it, and everybody lives in a region. The device itself can upload its data to a cloud service, and of course the service is managed by these very smart IT folks, right? Now you can tell why graphs are important to us as well. We can represent this as a graph. And this is only even a portion of the graph, because of course you realize that the admins probably have access to some HR internal systems, or they buy some stuff online. And the cloud service itself probably manages thousands of devices, not just one. So as you can see, we have an explosion in the number of identities, which leads to an explosion in the number of relationships we have to deal with. So that's quite new in our field, at least. The last problem is what I call the API explosion. And I'm sure you're all familiar with that. Every organization nowadays has a bunch of APIs. Every one of the entities, every one of the nodes in that graph, or entity types in the graph, or node types or labels, requires a bunch of APIs in order to maintain them. So you need to be able to get a user, the user needs to be able to change their password, et cetera, et cetera. And that's true for all the entities in our graph. But again, nowadays, we've seen that organizations have maybe thousands, hundreds, even thousands of APIs. So this is quite a big problem to be able to manage all the accesses to all of these things, right? So the problem then, identity explosion, relationship explosion, and API explosion. What can we do? Well, the solution, of course, oh, look at that. That's ugly. So we propose that graphs provide a solution, an elegant solution to our identity and relationship explosion. Of course, I don't have to convince you of that. I usually need to convince my identity counterparts. But as for the API explosion, we propose that GraphQL will help. That's the logo for GraphQL, right? Together, these tools form, are tools that we can use in our field of identity and access management solution to implement true identity relationship management. And I'll reuse that term later, but it's kind of a buzzword in our circles. There's been quite a bit of failure before with IRM, but we think that using graphs will really provide a solution and provide true IRM, identity relationship management. And you can see, you are graph people, you can see how that fits in, right? So graphs for identity. So let's have a look at how we use graphs for identity then. So well, that'll bind it all together. So how do we use it? We use it to model complex data. We use it to derive real-time access control decisions. And some future applications involve analytics. I mean, we already use some of that, especially for the authentication part, where we've had some cases where we can analyze behavior of authentication behavior and flag anomalies, for example. AI, of course, we hear a lot of talk about AI, but I'm sure there's use cases we can apply AI to in our field as well. So for authorization, we need to define access policies. Access policies are rules that derive the control, the access to a resource. So this is a simple way to model an access policy. An identity is related to a resource, and you have some verb that usually means, owns the resource or has access to the resource or is paired to the resource or something like that. So you can easily define an access policy like this. If there's a relationship between those two, then the identity can access the resource. Simple. Let's have a look at another example. Let's imagine this is the knowledge we have of our world. We have Bob and Mike, our friends, right? And then Jenny loves Bob. Now, interestingly, there's no other anyway, I'll let you ponder that. Jenny owns a car. It's a Renault. Mike owns a car. It's a Porsche. They're both red. Cool. Okay, so pretty simple. Everybody understands this. Now, here's our policy. People only lend their car to their friends. Fair enough. Here's a question. Can Bob borrow Jenny's car? That's a real access question, right? So how do we solve this? Well, I mean, we're graph people. We're going to run some cipher. So we need to match a person that owns a car who also has a friend. And this is Bob and Mike, because the question is, can Bob borrow Mike's car? And in this particular case, we have relationships with the car, and we actually find the relationships. So yes, in that particular case. If we ask the same question with Jenny and Mike, can Jenny borrow Mike's car? Well, in that case, we don't find the relationship. So in that case, there's no access, right? Easy enough. Hopefully that makes sense. So moving on, let's see a real example. This was from a customer we had a couple of years ago, I guess now. An IoT manufacturer. This is where I took all those pictures earlier. The context is that of refineries. They had a bunch of refineries worldwide with hundreds and lots of devices. And of course, the refinery is a complex environment with people and a bunch of things going on everywhere. And so these are the types of devices that we were dealing with. They're all smart devices in that they can be accessed remotely, or on their own, they can upload their data to a cloud service. So interesting stuff. So what was their problem? Well, first of all, a problem of volume. As I mentioned, identity explosion, 500 plus million identities spread out worldwide, and as many resources to protect. Because, of course, identities, especially when we're talking about IoT devices, they also act as resources to be protected at times. So they can at times be an identity, at times be a resource, and it's the same device. And they had very complex relationships between identities and the resources, and they had all kinds of crazy rules that they need to model. And all those things were really hard or impossible to model traditionally, like the directional relationships or, friends of friends relationships, which would lead to a table join explosion, in SQL. I mean, and they needed to resolve some path queries, like is there a path between A and B type of thing. And they also wanted, it was one of their is to implement a true identity relationship management system, true IRM. So that was the problem they were trying to solve. And of course, graphs were a perfect fit for that. And here are some of the use cases we implemented using Graph. For example, here, as a service or app, I need to be able to read data from a device. Pretty simple. That one's pretty simple. So I have an identity. I can read the device, and the device, or actually read device, it could be is paired with or is registered with. So anyway, so you get the idea. If you have this relationship, then the service can read the device. To revoke that access, I can just remove that relationship. And it all happens in real time and easy. Here's another one. As a factory worker, I need to register a device with the IAM platform using a given app. So I have a user that has registered with an app, and then there's this device out there, And I need to be able to pair it with the app and to declare that the user owns it. So this is basically what happens. And if I have these relationships, then I can easily deduce some access policies from that. If I need to revoke those policies, I can just revoke or delete those relationships, right? Here's another one. As a building owner, I need to be able to grant access to all or part of my building to certain users, for example, technicians. So let's have a look at that one. So I have a building that is made of several areas, in particular floors, and each floor has a set of devices. And then I have an owner of the building. And then this guy here tries to access that floor in order to service those devices. So all I need to do here is just add that relationship. And from here, I can find a path from that guy to the devices. So doing something like that with something else than a graph is really complicated, right? But this is just simple. I mean, they had much more intricate stuff. So putting it all together, we came up with a graph model that looked a bit like this. Now imagine, of course, 500 million plus nodes like that. Yeah. So moving on. So that was how we tackle usually the identity and relationship explosion problems. Now for the API explosion problem, let's have a look at that one. We proposed GraphQL, but then that's where we'll talk about that. So remember the API explosion problem? We had all these entities and all these APIs we had to manage and control the access to and all that. Well, wouldn't it be nice instead to have just one single endpoint, REST endpoint there, that would cater to all these entities? Not only the entities that I have now, but also all the entities I will have. Wouldn't that be nice? Well, that's exactly what GraphQL proposes, actually. So what is GraphQL? I mean, before going further, are you guys already familiar with GraphQL? Any show of hands? Everybody's, oh, okay, well, okay, so I'll just go very fast on that one. So you all know this, generic query language. Facebook created it. It's a specification, meaning you can build your own, basically. One REST endpoint, and works with any backend store, but it works greatly with Neo4j, right? So, okay, cool. So this is how it works. We have a client. I just like this laser pointer. It's pretty cool. So we have a client with a GraphQL client library embedded in it. It packages a query that looks like this, which goes to a server. The server understands the query, transforms it into using some custom code here, which could be JavaScript or your favorite language, into a query that looks like this, for example, Cypher query here, to the database. The database returns data, and the GraphQL server packages a response that looks like this. So here the query was for a user, and we requested the UID, the email, and the username, and we got that back in this format, which is also standardized through GraphQL, which is a specification. And the client understands that and displays it. So to really make sense of the power of GraphQL, we have to zoom in on the server. And if we zoom in on the server, GraphQL works by defining a schema. And the schema is made of three things. The first being a set of types. So these are the types, the object types or the entity types that you have in your database that you are willing to expose to your client. So you don't have to define in your schema all the types you have in the database, only those types that you are willing to expose to the client. Then you have your queries, which are your reads, and your mutators, which are your writes. So a query, through the query, you can get your data. Through the mutator, you can update it. The mutators and queries are implemented through resolvers, and the resolvers use your favorite programming language, for example, Node.js. Yeah, so the next slides, I'm going to show you some code. Hopefully nobody is allergic to code. I don't have an EpiPen. Anyway, and the code I'm going to show you is basically we at Nulli built our own identity and access management platform using GraphQL from the ground up, running on microservices and all that. It's all Dockerized and everything. And so that's what I'm going to show you. Oh yeah, the database. I forgot that. So again, the schema is made of types. And so here, as I mentioned, we wanted to implement true IRM. And because of that, the relationships are first-class citizens. So we, of course, have a type relationship. But we also have user types and location types, device types, domains, and what have you. So we have a bunch of types that we define, which map to types of data that we have in our database. So our relationships have a start label and a start UID, and then an end label and an end UID, and a relationship type, the label of the relationship. Pretty straightforward. And we have a bunch of types like this. And you see, these are just definitions. There's this simple code, and that's all that the type is. The second thing in our GraphQL schemas are, whoops, going too fast here. Oh, queries. So these are just a sample, just a subset of the queries that we've defined in our GraphQL schema. As you can see, the queries are just definitions. If you are familiar with object-oriented languages, they're a bit like interfaces. It's the contract between the server and the client. And it's basically just, it's basically just a name and a set of input parameters and an output type. So if we look at this one, for example, can A access B? This is a query that you would basically run in order to ask to evaluate the access that A has on B. So if you have A being an identity and B a resource, you want to check if A can access B. Basically, what we're doing in the back end there is finding the path between A and B, and if that path exists, then we grant access. So for that, of course, we need the UIDs of A and B, and it returns an array of relationships. That's because more often than not, A and B are basically separated by several relationships. So we really need a path. Mutations, same thing. We just have a set of definitions for the type of things that we can change in our data. So you'll see things like reset password, update your user profile, create a user, activate the profile, register your social email, and things like that. So all of these things, as well as the queries, need to be implemented through code with your resolvers. So here's an example implementation for our can A access B query. Now this is just JavaScript code. The only important piece here is this one, this row in the middle there. What that does is it reads a Cypher query from file, executes it against Neo4j, and returns the result. I mean, the rest is just plumbing at this point. And the query that we are reading and running is basically that. And as I mentioned, we're just finding the path between A and B. And if we find that path, then we can grant access. Pretty easy. And so this is what a query at runtime could look like. We just package it like that and run it through our one single REST endpoint, for example. So this is what that request would look like. And this is what the result would look like. In this case, we just have one single row in our response because it was a simple relationship. But we could, again, it's an array of relationships, so we can have several, and that defines a path. Okay, what else? So now, the grandStack. Now, all this is fine, but as I mentioned, and as you know, GraphQL is a specification. So you're saying, well, okay, that sounds like lots of work. I have to implement all of this stuff myself. Well, no, there's the grandstack, the grandstack. All of these things have been already done for you. All you have to do is use it. So what the grandstack is the integration of Neo4j, the Apollo GraphQL server and client, as well as React.js for the client UI framework. Now, these things have been, people have Neo4j and React. I mean, they've been working together and packaged everything together neatly so that you can just download this stuff and just get ready and just work on it right away. It's pretty good. So this is how it all integrates together. We have React.js on the client with the Apollo client library running GraphQL, and the Apollo server here running the GraphQL server. We still need to implement our own resolvers, of course. And we have Neo4j here. And that's basically how that integrates together. And you can have a look at grandstack.io and download this stuff, and you can just get going. Yeah, I guess I'm reaching my last slide now already. So what's the typical roadmap? I mean, how do you go about building something using GraphQL? Well, of course, you start with your business requirements. Then you define your graph data model. So, I mean, you're all familiar with that. You just draw it and whatever you usually do. For the GraphQL part, you need to define the schema. And we found the important piece here is to describe the schema in the way your clients will use it. Again, you don't have to define everything. You don't have to expose everything. You just need to expose exactly what your clients need to use. No more, but no less. Then you implement the backend, your resolvers and mutators, and you integrate Apollo into the client using React.js, and you're done, essentially. So that's, let's see, I'm a bit ahead of schedule, I guess. That's all I had for you, so I guess I have time for some questions, if you had any questions.
Have you handled denying access? Say you gave the tech access to level 1, but you shouldn't have access to a specific instrument on level 1.
So how do I deny access, basically? So as I mentioned, we have relationships, so that encapsulates your access. If you remove the relationship, then you don't have access.
But if you want to give a general access to a whole building,
right,
but then deny access to a floor in that building.
Oh, right. Okay, let's, well, if you remember the graph, we had the building had a bunch of areas. Well, you can, for that particular user, you would probably create, you could infer some relationships between the user and the specific devices, I guess, or the specific floors. I guess you could also define deny relationships. Presumably, you could do that if that helps. Yeah?
So does it use historical data? Meaning, if you break that relationship, can you go back sometimes? So this user had access at a certain point in time.
Yeah, I mean, you can store dated data in graphs. I mean, it's been done. You would have date nodes, and you would attach the dates to certain other nodes. So you can do stuff like that. There's articles and blogs about how to do dated data. I don't think we've used, I mean, I haven't used that direct. No, I don't think we've used that much, but why not? It is possible, though. Yeah.
Is there a way for this model to cover granting access or not to individual properties of an entity? Like
right.
You see the name of the employees, but not the salary unless you are HR.
Right. So in that case, so the question was, can we use that model to grant access to specific properties? So in that case, you might have to actually export that property and make it a node, maybe. So you would create a relationship to that node. That might be a case where you could do that, or else you could, through your, if you didn't want to do that, you could use your resolvers to implement that through code somehow based on the relationships that you already have. Something like that. Sure.
In your GraphQL schema, you have the relationship type for the entire route from the accessor to the resource returned in that request. Is that there mainly just for like proof of work, or is that actually used there to also define access inside the GraphQL API? And if that's too proprietary.
No, you can use the same. You use the same for both, basically. So the question was, can you use the schema to also protect access to GraphQL itself, to your REST endpoint? And yes, you can. The GraphQL specification actually advises you to do all these types of authorization in your resolvers. So basically, your resolvers, you could run extra queries to figure this out. Yeah?
It seems like in the use case you laid out, I mean, I know you say you work on identity management.
Yeah.
Primarily, but your database is, the data in your database, that's its entire purpose, right? Like you're adding a node for that building, the use case that you had described, in order to define authorization to it. So
So your question is using the graph as your main data source, really,
Yeah.
not just for authorization.
Right, yes, like in conjunction, so to embed
Right.
access information in there as well.
Right. So yeah, I mean, right now, as I mentioned, well, as I mentioned at one point, the main store right now for identities for our world is LDAP, and that's not going away. So because there's so many things relying on it nowadays, but we've been using graphs in conjunction with LDAP. But we started to see some clients that are willing to move more to graph. So it's in progress, I guess. I don't know if that answers. Maybe I have just one more question over there. You were first.
I wonder you talk about in terms of the API explosion, how a lot of those other endpoints exist outside of the platform, and what you're doing, like you're only taking the information that you're needing, but in terms of keeping those things in sync, are you restoring data in both places, or how's that?
Right. So I guess if you have both, if you have the, so the question is, do you have to maintain the data in several places, basically, right? If you're doing that, I guess you do. Yes, you have your LDAP entries with the user account and the password. Specifically, is more for the password. That's where you bind. But all the access or access management stuff would be in graph. So your code or your platform will need to differentiate what type of data you're updating. Is it access control data and then you update the graph, or is it more authentication stuff, or and then sometimes it's both. But yeah, you're right, it does add some complexity there for sure. I think that's all the time I had. Thanks everybody, and if you have more questions, feel free to reach out.